Welcome to Tech Unheard, the podcast that takes you behind the scenes of the most exciting developments in technology. I'm Rene Haas, CEO of ARM. At ARM, we're shaping the future of computing with the industry's most powerful and energy-efficient compute platform, designed to unlock the full potential of AI. Our technology is at the core of innovation for leading companies across the globe. In this podcast, I'll be sitting down with some of the brightest minds in the industry to share insights, stories, and vision for what lies ahead. Today, I have the privilege of speaking with Jensen Huang, the CEO of Nvidia, a true visionary, my former boss, and a personal mentor of mine. We're going to dive into his journey, the future of AI, and how Nvidia's unique culture of relentless innovation and ambition continues to push the boundaries of technology. We sat down and met at Nvidia's headquarters in Santa Clara to talk. Ready to go?
I was ready the moment I walked in.
It's great to be back.
Well, thank you.
Yeah, it's great to be back.
It's great to see you.
It's great to be back here at Nvidia. This building did not exist when I worked here many, many years ago.
How many years ago now? 20?
I started in 2006. I left in 2013.
Okay. Yeah, see, 20 years ago.
Yeah, 20 years ago. These buildings did not exist. It's a nice feeling to be back, though. Familiar. Thanks for spending the time.
Thanks for having me.
So now that you've grown so large, one of the things I've always been curious about, Jensen, with Nvidia is hiring. The culture is one of a kind. Company does things in one of a kind way. How do you identify folks who are going to be successful inside Nvidia?
We're not always successful in doing that. Look how you turned out. It's always a shot in the dark. I think that the interview process is not an excellent way to judge whether somebody's a good fit. I mean, obviously, everybody could pretend to have a very constructive conversation. You could learn a lot from just watching YouTube on how to interview. And so, the technical questions, of course, people even share what NVIDIA technical questions are. And we try to be as rigorous and difficult as possible, but it's hard. I think that my method is always, I go back to reference checks, and I ask them the questions that I was going to ask the candidate. And the reason for that is you could always make for a great moment, but it's hard for you to run away from your past. And so I think those are good. I like asking one in-depth question and just thinking about how they reason through it. But I think in the final analysis, NVIDIA has been successful for a lot of people. Our attrition rate's very low, as you know. Right. And it's a really diverse environment and with a lot of really interesting people in background. And we have people from just about every great company in the world. And somehow we've made them successful here. So I think that on the one hand, building a great company is about getting great people. On the other hand, building a great company is really about creating the conditions by which those people could do even better than they thought they could. And, a lot of that has to do with being transparent about explaining what NVIDIA's vision and strategy and what makes us work. As you know, I spend a lot of time doing that. And our company has always been known for its transparency about explaining what challenges we have, what opportunities we have, what strategies we're executing. And information is flowing fairly readily inside the company with respect to, what is it the company's strategies are. I always find that it's strange when companies have too many silos and, need to know basis. I think obviously, people don't need to know what they don't need to know, but the more that they know, the more they're empowered to be able to make good decisions on our behalf. And so I try to err on the side of transparency. I try to err on the side of empowering people. And as a result, the company is I think we're the smallest large company in the world.
For sure.
I think that comes with the incredible productivity of the people. And we got 30,000 people or so, maybe a little bit more than that now. And they're making hundreds of decisions a day. And if all 30,000 of them are, statistically moving in the direction, making decisions that are ambiguous decisions oftentimes, but they're making it in the direction of what is in the company's best interest long term, it adds up really fast.
One of the things that always amazed me is that, back to that point, and again, I don't know whether it was hiring the right people or self-selection, but by having senior leaders who were extremely comfortable with the ambiguity and the fact that you would reach down into different layers of the organization, i.e. the project is what's most important. I just wondered, how did that happen? It's just something that as you grew the company and you had senior leaders who were aligned with your vision, that it grew up that way? Because it's just amazing that so many of the senior leaders here, when I worked at Nvidia, they were completely fine with the fact that you would just reach around and get the right people in the room to solve a problem.
Well, first, I didn't ask them, as you recall.
That I recall.
And the reason for that is because you shouldn't have to ask permission for something that is that obvious, And so the reason why we said it that way is that NVIDIA was designed to be a full stack computing company. We were designed to be a company that would build GPUs and CPUs and networking chips and switches, and we would do architecture and design of chips and develop system software and create algorithms and even, create solvers. And so how would you organize such a thing where everything has to work together on the one hand, but you have to build it in parts on the other hand?
Yeah.
And so the way we solved that problem was, instead of having organizational silos, we thought of the organizations as a place where the leaders can groom people, create conditions for them to succeed, be of service to them to help them remove obstacles and such. But the mission is the boss, and it cuts across the whole company. So it can cut across systems and chips and networking chips and software and algorithms, and it can cut across all kinds of domains. And by organizing that way, we also created transparency. All these silos became porous. And when organizations are porous, it tends to be better, because you have a lot more people who are able to help you criticize it. You have a lot more people who help you improve it. And so I love the porosity of our company, if you will. I just love that everything is transparent and everybody's helping me make it better. And, it's not like everything is in some kind of dark silo.
You almost acquired us, which would have been fun, but you acquired Melanox.
I know you're still sad about it.
I'm still sad.
Yeah.
Every day I cry a little bit, but I'm here.
Thank you.
But
you guys have done so well.
But you did acquire Melanox, which has been not only an amazing acquisition in terms of your strategy, but it also just seems like seamlessly, to your point of a porous organization where the mission trumps everything. Mm-hmm. From the outside in, it looks incredibly seamless in terms of execution. How did that happen? I mean, how did you make that so? I mean, M&A is so tough.
It is
culturally
tough.
Very tough.
Yeah, it is tough. Well, first of all, there are 10 people, I think maybe more, 10, 12 people on the Melanox management team, the NVIDIA Israel management team, that sits on eStaff.
That's great.
We have
that makes a difference.
Architecture, we have research, we have software, systems, the chips, we have NICs and switches, we have NVLink switches now. We used to have just InfiniBand product line, but now we have a whole Ethernet product line.
Yeah.
In the short time that we've been together, the product portfolio of Melanox, quadrupled, and they're integrated into every aspect of everything we do. If you look at the transformation and you recall the acquisition, our vision was that the unit of computing was no longer going to be, for example, a GPU, which is really a peripheral. ARM helped us, in fact, quite importantly, to transition into a company that was building an SoC.
Yep.
Now, remember what an SoC is. An SoC is basically a whole computer,
yep.
Whereas a discrete GPU is the last thing that comes up in the computer. The CPUs come up, the boot ROMs come up, the operating systems come up, and eventually the GPU comes up. In the case of an SoC, you have to bring the whole thing up yourself. And so it caused NVIDIA to evolve from being a algorithm company, which is really what a GPU company is,
right,
to a computing company. That was our first entry. And the SoC wasn't easy for us in the beginning. We built some amazing ones now. And then the next evolution for us was building systems. And DGX-1 was our first. In fact, I'm still quite fond of Shield, which is our Android TV computer. And I'm very fond of it because it was really NVIDIA's first full system that we created. And
the learnings on Shield must have been amazing. Not looking back, because I remember when we started that.
Yeah, it is still the most popular Android TV box that people...
Back in the day, it was a PlayStation, Xbox controller with a display. And we were just thinking to ourselves, how do we do this?
Yeah, it is still my favorite thing that NVIDIA has ever made.
I completely forgot about that.
Yeah, those were the good old days.
That was a system.
Yeah, I learned a lot.
Yeah.
I learned a lot. And to this day, we're still maintaining the software.
Yeah. It was utterly unobvious that there was a fit in the marketplace for this. And I remember folks inside the group suddenly having to source a whole set of components
Yeah, right.
and a bomb that
like I said,
we had no idea
it
what we
made
were
us
doing.
exactly. It was my excuse to turn Nvidia into a systems company.
Yeah.
And people will ask me, the DGX1, which is the computer that changed everything.
Right.
Well, how did that come about? Well, DGX1 is just a very large shield.
It's a very large shield.
Yeah.
Yeah, exactly.
And so to me, the fact that shield was made out of plastic and DGX1 weighs 600 pounds, that transition wasn't a big deal. The big deal was that we were now able to build systems. And then when we bought Melanox, the big idea was that the computer was no longer going to be that node, but the computer is going to be the entire data center, that the data center is going to be the unit of computing.
Right.
And if you don't design GPU, the CPU, the NIC, the switches, all of the transceivers, and connect everything together and be able to boot that system up, from nothing and get everything all wired up, get everything all running and distribute workloads across it. If you don't do that, you're really not going to understand what it means to build these AI superclusters. And that transition, that vision was so clear that it was necessary for galvanizing the two teams. In order to galvanize teams, you have to have a very clear vision.
Right.
And we had a very clear vision. And that vision was also very tangible because you could see it.
Right.
Sitting right in front of you, there's supercluster and it's got all the gear from both companies. And so the vision was clear and inspiring. It's tangible, or we have to make it tangible. As CEOs, you have to make abstract things tangible. And we went off and built it. And so anyways, I also think that their culture is great.
Yeah, and that clarity really helps. But going back to kind of the vision thing for a second, and this is another thing that when I tell stories about the company, Shield's a good example. CUDA in the early days, chasing oil and gas is a good example where it's completely unobvious.
Yeah, people didn't realize that. In fact, that was our first.
That was the first.
Yeah, that was
completely unobvious what the real end quote killer app or end state is. Yet you have an incredible resiliency to experiment with ideas early and test them, even though the market doesn't either appear ready and or there's even a definition for it. What do you chalk that up to? Is that incredible intuition? Is that seeing around? I mean, what do
we've had good intuition, 10 times in the company, as you know. And the benefit that Nvidia has is we're surrounded by extraordinary people. I mean, these are the finest computer scientists, the finest strategists and business people in the world, and they're egoless and they want to do great things. And so I think that one, we start with that. I think the second part is we're good at intuition. I think we have a good intuition about what problems need to be solved and how to get us from where we are today to becoming the company we want to be. And so I think our intuition's good about what the various stepping stones are. And each one of the things that we did, I was asked, why are we building Shield? I mean, what a waste of time. And I said, we're going to be a systems company someday, and all these systems are going to be connected to cloud services. Why go break our pick on the largest systems? Why don't we do this one first? And if we can't do this one, we're not going to do the large one. And so to create the conditions where the company could go learn some new skill, fail, but not damage yourself, and so.
Can that only happen at companies where the leader is or was a founder? Because again, very, very few companies do what you just described, both in terms of having clarity of the vision, but also resiliency to continue to understand where to go. There's been a lot written recently about founder mode versus manager mode. And obviously you're founder leading a company 30 years later. It goes without saying the amount of success you've seen. But can this only be done, what you described, by the founder leading the company?
I don't think so. I think you're doing great at ARM. When I watch you do your work, I'm very proud of it.
Well, I learned from you, which is being truthful.
Yeah, and I love watching you do your work, and it makes me happy. Brings me great joy and pride. I don't think so. I think that it is true. You have to have great resilience, and you have to have perseverance, and I describe it as pain and suffering, as you know, and
teaching moments.
Yeah, pain and suffering is how you feel.
I felt it.
And, yeah, and in a lot of ways, you have to get used to it. you have to get used to the idea that there's pain and suffering involved, and that the journey to success is not about one achievement led by another achievement and another achievement. It's not like that. There are big setbacks sometimes. There's embarrassing moments. When you're a CEO and you haven't enjoyed any of that yet, but
it'll happen.
Well, I hope it happens because it will be good for you.
Yeah, absolutely.
But all those moments are I don't know what I learned from it, but it made me stronger.
Yeah.
And I know I could survive it. I know I didn't like it at the time, but when I look back on it, those are the moments where you
grow.
That's right.
Where you grow.
You're the most proud of yourself. You're most proud of your company, and that you survived it. And so I think our company is strong because we have lots of stories like that.
Yep.
In the halls of this company are just filled with extraordinary stories of one setback after another setback after another setback,
and with many leaders who went through it.
Yeah, most of them are kind of like, oh, this isn't nearly as bad as when that happened.
Right.
Every time something happened, it's like, it's not. This is nothing. So the ability to be able to go directly to, remember when that happened?
Yeah.
This is nothing, and yet this is incredibly painful.
Yeah.
It helps the company move through these challenging times.
So you and I have been around this industry about the same amount of time, and some of the stuff that's going on with AI, I know I feel this way, were things that I just thought I would never see, that the future generation would be able to experience the kind of transformation that seems to be taking place. It feels like to me, not to sound Star Trek-y, but this is the final frontier in terms of, I can't imagine what is next beyond what we're seeing with artificial intelligence. Broadly, how do you feel about it? Are we accelerating so greatly the transformation of an industry that we've never seen before? Is there anything next after this? It's just unbelievable what we're seeing.
I guess I've always expected that computers would demonstrate intelligent behavior, that we would be able to write software so well, and I thought we would write it, that algorithms would eventually solve problems in a way that seemingly the computer is intelligent. I never thought that it would result in an industrial revolution. And
Right.
what I mean by that is, and you've heard me say this, that for the very first time, the computer industry has now transcended beyond the traditional computer industry. That for the very first time, we're now no longer a tool, an instrument, but we're now a manufacturing industry. And so what I mean by that is, right now, while we're talking, our phones are in our pocket, it's not being used. And when I'm not using it, I'm not using this tool, it's not doing anything for me. And most computers are that way. My laptops in my office is doing that. Most people's computers are that way. If you need that tool, you go use that tool. However, this new industry of AI factories, which is what we're building now, they're running all the time. Whether you're using it or not, they're producing tokens. They're ingesting data, they're producing tokens, they're generating intelligence. Intelligence is being manufactured at a very large scale. And the idea that this computer used to be an instrument, a tool, is now a factory, a manufacturing thing, and that is producing incredibly valuable things at very large volumes. And so this is a new time for our industry, as this has never happened before. And the idea that computers are now the manufacturing instruments, the machinery behind this incredible thing called tokens, intelligence tokens, is just an extraordinary idea. And so we're at the beginning of a new industrial revolution.
Is it racing faster than you thought it would? You've been closer to it probably than anyone with AlexNet and DGX1, and have seen the pace of innovation. From where I sit, and we've been looking at it inside ARM quite deeply since I took over, it has gone far faster than I would have imagined 2.5 years ago, far faster than I imagined even a year ago. Mm-hmm. You're involved in everything around it. Is it moving even faster than you imagined?
No, we're trying to make it go faster.
Mm-hmm.
We've gone to a 1-year cycle. And the reason for that is because the technology has the opportunity to move fast.
For sure.
And because we are now not just building chips, and we know that the rate of progress of chips anymore, if you're lucky with a new process node to get a few percent, that's incredible. And so how do we get X factors of performance with each generation? Well, the way we solve it is we design 6 or 7 new chips per system. And then we use co-design to reinvent the entire system. and invent, new things like NVLink switches and new system racks that allow us to drive copper across the entire back spine of a system to connect all of the GPUs together in very large packages and 3D packages and such. And we're using all kinds of techniques to do that. As a result, we could deliver 2 to 3 times more performance at the same amount of energy and cost every year. And that's another way of essentially reducing the cost of AI by 2 or 3 times per year.
Yeah.
That is way faster than Moore's Law. And so you compound that over, right, 5, 6, 10 years, we're able to drive incredible cost reduction for intelligence. And the reason why we're doing that is because we think that this is at a time when we all realize the value of this. If we can drive down the cost tremendously, one, we could do things at inference time like reasoning. Today, when you use ChatGPT, which is an amazing service, I use it every day. I used it this morning. You hit enter and your prompt is loaded and it generates the output. But in the future, it's going to iteratively reason about the answer and come up with a tree search maybe, and maybe it does some kind of iteration and reflect on its own answers, and eventually it produces an output. It might have gone through 100, 1,000 inferences, but the quality of answer is so much better.
Yeah.
We want to drive the cost down so that we could deliver this new type of reasoning inference with the same level of cost and responsiveness as the past.
I have seen a demo of the OpenAI model that does reasoning, and it was shocking, to your point. It went through a logic tree. You could see the trade-offs it was making simply the way a human would, yet at a pace completely unlike the way a human would. But then as you fast forward, and this is what's so fascinating to me about this, what's going on now, is that exactly to your point, you're introducing systems, full data center infrastructure at a pace the industry has never ingested at before. CPUs bought every 2 or 3 years, they're ultimately depreciated. Yeah. Now you're building systems on an annual beat. Yeah. People want to pay for those systems and deploy them as fast as possible.
Yeah. Right now where we're talking, it's so easy to say, but we're delivering new computers that are this room size each year. All the cabling, all the networking, all the switching, all the software. It's really quite insane.
Do you see it? And I'm not asking you to forward forecast, but this is more just a technology ingestion question. Can it continue at the current pace?
Yeah, I think so. But it has to be done in a systematic way, in the sense that everything that we do in an architectural way. And what that means is that the software that you develop for yesterday's clusters, like Hoppers, and that software is going to run on Blackwell. And that software will run on Rubin. And the software that you create for Rubin is going to run on Hoppers. Well, this architectural compatibility is really quite vital because the investment of the industry on software is 1,000 times larger than the hardware. Not to mention, no software ever dies. And so if you develop software, re-release software, you've got to maintain the software as long as you shall live. And so the architecture compatibility, that the idea of CUDA is not that there are millions of people programming to it. The idea of CUDA is that there are millions of GPUs, several hundred million GPUs that are compatible with it. Yeah. Software doesn't die.
Software doesn't die.
Yeah. And so whatever investments that you make on one GPU, you can carry forward to all the other GPUs. And all the software you write today will get better tomorrow. All the software you write in the future run in the install base. Yeah. And so, number one, we have to be architectural and really disciplined about that. Second, even at the system level, we're super architectural now. We'll change pieces of the technology to advance system design without you having to leave everything that you did yesterday behind. And so, for example, when we first came into the data center business, a hyperscale data center had power distribution that was like 12 kilowatts per rack. Well, Blackwell's 120 kilowatts per rack. It's 10 times the density. Now, of course, it's 10 times the density, and it reduces millions and millions of dollars of servers and compressed it into one rack. Right. And so the amount of savings, energy savings, and space savings is just incredible.
That is very similar to our story. The ARM architecture has been around for 30 years, and we have software that's been written for it for decades.
Exactly.
And that is what people sometimes don't always understand.
Everything we develop on every single ARM chip, we carry forward. We just showed something the other day. Somebody did some benchmarking, and Grace was 4 times the performance per energy per watt than the best CPU in the world. And
bravo.
energy efficiency is vital. It's everything.
Do you see anything architecturally starting to break when you go from 500 megawatt data centers to 5 gigawatt data centers, just relative to the network, latency, things of that nature? Without getting into proprietary stuff, do you kind of at a high level physics standpoint start to see some things that start to break?
Everything breaks. Physics is obeyed, which is the problem. But everything breaks. First, of course, we're moving up the power density curve very, very quickly, exponentially. And so from 12 kilowatts to 40 kilowatts to 120, 200, and it's going to go beyond that. And so we're trying to compress, densify computing as much as we can. When we do that, of course, liquid cooling becomes more efficient. When we do that, we can use copper for longer. Copper using electricity for as long as you can is good so that you don't hop across electrical to optical. We'll ultimately have to go optical, but we'll stay with electrical as long as we can. And so as much of the data center as we can, it's more cost effective, it's more energy efficient, it's more reliable. And so that causes us to densify. The other benefit of densification is that all of the GPUs that are in a particular rack or in adjacent racks can behave as one giant GPU. It's really quite amazing.
Amazing.
Yeah.
One of the things I've always been curious about, Jensen, is keynotes that you did at Computex. I remember watching the one you did, I think it was on a Sunday night. And the sheer volume of content that you go through is not only unbelievable, but as someone else who does keynotes that are not nearly as long or as in depth, I just marvel at how you pull that off. Do you do massive amounts of rehearsal for it? I remember back in the day when we worked together, I remember changing them at times the evening before, and you still pulled them off. But now, the level of depth that you go into, particularly given back, you're talking about a data center architecture, you've expanded it out. How do you prepare for it?
Well, we're preparing for it every day. That's kind of the nice thing about our job is we're not actors. And so this is kind of our job. We kind of live in it.
Right.
And so number one, we're preparing every day. But a lot of what you and I do, frankly, is teaching.
Yeah.
In order to shape an industry, in order to shape the market and to introduce new ideas like what we're trying to do, a lot of it is teaching.
For sure.
It's not advertising.
For
It's
sure.
not, and we're a platform company, meaning we can't really do what we do without other people doing it, with us.
100%.
And so we're about teaching, inspiring, showing, maybe demonstrating, and hopefully step by step, we get more and more believers in CUDA in the beginning, Nvidia accelerated computing today, and joining us in our journey in AI. And then now the next big thing that we're working on is physical AI. And how do we teach AIs that obey the laws of physics on the one hand, and then also understand the physical laws on the other hand? So I think the journey is fairly long. And so, GTC and Computex, these are opportunities for us to do that, to celebrate our ecosystem and the work that they've done, teach them, sort of inspire them about the next.
Quite similar. We'll do QBUs, I'll do presentations, and my chief of staff will say, gosh, the slides were easy. That's kind of what you say all day. And I'm thinking, well, how could it be different?
It's still hard, though.
It's still
to be
hard.
honest, because we don't practice. So it's not because we choose not to practice. By the time we get all the stuff put together, there is no time to practice, and so we just grip it and rip it.
Jensen, thanks much.
It's great.
Really appreciate
Great to see you. Good job on everything you're doing. Proud of you.
Thank you. I'm Rene Haas, CEO of ARM, and it's been a pleasure to have you with us today. And thanks again to Jensen Huang for joining us for our very first episode. We'll be back next month with more exclusive conversations and insights from the world of technology. Make sure you follow Tech Unheard wherever you listen to your podcasts. Thanks for listening.
ARM Tech Unheard is a custom podcast series from ARM and National Public Media. Executive producers, Erica Osher and Shannon Boerner. Project manager, Colin Harden. Creative lead producer, Isabel Robertson. Editors, Andrew Meriwether and Kelly Drake. Composer, Aaron Levison. ARM production contributors include Ame Badani, Claudia Brandon, Simon Jared, Jonathan Armstrong, Ben Webdell, Sofia McKenzie, Kristen Ray and Saumil Shah. Tech Unheard is hosted by ARM Chief Executive Officer Rene Haas.